essentially, there's a couple things mainly with continuity that I need you guys to understand. And we've done you did a little bit of continuity stuff with advanced math. But when we look at this, the only graph that's continuous is the first one. Okay. The second one is what we call a jump discontinuity. This third one is called a removal discontinuity. And this is your vertical asymptote situation, which we will, for right now, you call it a vertical asymptote. We will eventually call it a vertical tangent. But I have to define for you what the word tangent actually means later. But technically, it's defined as a vertical tangent. Jump discontinuities occur when you have piecewise functions. Removal discontinuity is when you have polynomials and fractions. And that's also the same thing for a vertical tangent, but you could also have a situation, just kidding. Essentially, you have, for both the vertical tangent and the removal discontinuity, your situations are, you had a fraction over a fraction, and you're left with something in the denominator that gives you the vertical tangent part, and your removal discontinuity comes from canceling the term out. Okay. Continuity of the graph has no holes, no breaks, no jumps, so we can be rest assured that it's continuous. Continuous functions are simply nice, smooth functions that can be drawn completely without lifting your pencil. So you can trace along the entire part of the graph without lifting up your pencil. Okay. And then we say that a continuous function is like a well-built roller coaster. There's no brakes. You know, that would be funny. Not funny. Funny and not funny. The brake and the roller coaster. But there's no gaps or holes in the function. Okay, there's a more mathematical definition for continuity, and really what it states is that your left side and your right side are equal to each other, the limits, and it's equal to, bless you, f of the point. So when right side and left side limits are equal to each other, you have an overall limit. And then once you have an overall limit, that overall limit is also equal to f of 2. Remember you had those situations where you're like, oh, there's an open circle and a dot above or a dot below. It's still not continuous because the dot wasn't filled in. But if that dot is filled in, then it is continuous. Okay, and so you'll be asked a couple things with continuity. One, you'll be asked to force continuity. That is in example 2. And then in here, for this particular one, you'll be asked to say, is this function continuous or not? So if you're asking for if the function is continuous, what you're going to do is show right side and left side limits, see if they're equal to each other. You do have to show the limit notation, and you have to show that it's also equal to f of the point. If all of those match up, then the function is continuous. If they don't match up, then the function is not continuous. Okay, so we look at the limit of x approaches 2 from the positive side. That is your 2/3 x plus 2. Thank you. So you plug in your 2 in for your x. So you get 4/3 plus 2, which is 4/3. Plus 6/3, so you get 10/3. Then you plug in 2 from the left side, and you get -2 plus 1, which is equal to -1. These two are not equal, so the function is not continuous. F of 2 does not exist, and then technically your, which does not exist, and your f of 2 is negative 2 plus 1, which is negative 1. But essentially, the first thing that you check for continuity is whether or not these two are, your right side and left side limit, are equal to each other. Once you show that they're equal to each other, then you just have to show that f of the coordinate point is also one of those values. Okay. Typically, with a piecewise function, you will have, once you have left side and right side limits are equal to each other, it will be equal to f of the point, even though you have to show it. The only time you get a piecewise function where it's not the case is if I had, here and then another line that said when x is equal to 2, y is equal to 7, for example. Then just by looking at it, you would know that it wasn't continuous. Questions about that? Yes. F of 2 is where the equal sign is on the domain. So that's why it's the bottom equation and not the top. Other questions that you guys have? So I just talked about it in the other example, but this also gives you another, back to the original example that we talked about before. You have your removal discontinuity, and then we can call this a vertical tangent or an infinite discontinuity. Okay. The only other thing that College Board asks you to do is to force continuity. So what ends up happening is you have this situation here, and I want to know what value of k can I have so that this is continuous all the way through. Okay, so essentially what I want to do is if I'm checking for continuity, I want the left side and right side limits to be equal to each other, and I want it to be equal to f of the point. One of these will include f of the point, so really all I need to show is, or make force into a situation is both of these have to be equal to each other. And they have to be equal to each other where my domain splits up, which is at x equals 2. So I want to find the value of k so that both of these equations are equal to each other when x is equal to 2. If I'm asking you guys this on a multiple choice test, I don't care about you showing me limit notation. I will tell you that every once in a while this shows up on a free response, open-ended question, and so you would have to show the limit notation. Because you will have to show the limit notation on a free response, I'll show you the limit notation now, and then for you guys just to know that I could, on a multiple choice, plug in 2 in for my x's and set them equal to each other and solve. And that would be a quicker way on a multiple choice test to solve. Okay, so take the limit. X approaches 2 from the negative side of f of x, which is 4x minus 5k. And you're going to set this equal to the limit as x approaches 2 from the positive side of 3kx minus 5. Because I'm using the limit notation, I can, and there's no 0 in the denominator, I can plug in 2 in for all of my x's. So I get 4 times 2 minus 5k is equal to 3k times 2 minus 5. So 8 minus 5k is equal to 6k minus 5. Add 5 to both sides, so I get 13 is equal to negative 5k is equal to 6k. Add 5k to both sides, and I get 13 is equal to 11k. Divide both sides by 11, and I get 13 over 11 is equal to k. What that means is that when I plug in 13 over 11 in for both of my k's, this function is continuous at x equals 2. That's what it's saying. And it's only continuous if my k is equal to 13 over 11. If my k is equal to any other number, it is not continuous. There's no other number that will work. Okay.
questions that you guys have.
So you have a 1-5 assignment. You have a review assignment. Just so that you guys are aware if, you know, my plan is to start putting zeros in between third period, I think about the number, third period and lunch today. So if you don't want to do any explaining to your parents why you have zeros in the grade book, make sure you guys get your grade scope stuff uploaded. I won't put in zeros for 1-5. I don't do that typically to you guys. So really, your zeros are going in for 1-1 through 1-4. Okay. You do have a review assignment. That review assignment is already posted in Google Classroom, and it is a Google form. Okay. I don't mind that you guys do it multiple times. It's better if you do it in one straight shot, because it's easier for me to upload into PowerSchool that way. But if by some chance you have a situation where you need to do it again for whatever reason, send me a remind message and I will remove your entry so that way you can just submit it again. Because sometimes you accidentally submit because it's on your phone. Okay. And then also when you guys are uploading a grade scope, make sure that if you're using the app, that you are selecting the pages that go with each question. Okay. All right, we just have the rest of class for you to work.